Hello there, and welcome to the Dozing Explorer. I am so glad you have found this quiet space tonight. There is a place here for you to let the day dissolve, a gentle harbor where you can simply be. So settle in, feel the weight of your body being held, and allow each breath to be a little softer, a little slower than the one before. There is nothing you need to do, and nowhere else you need to be. Tonight, we will not be studying or trying to understand a complex theory. Instead, we are going to drift on the slow, deep currents of one of the most beautiful ideas ever imagined, Einstein's theory of relativity. We will not look at it as a lesson, but as a landscape. We will wander through its quiet, starlit fields and listen to its gentle, cosmic music. Think of these ideas not as facts to be learned, but as soft, glowing lanterns, each one illuminating a small, wondrous part of the universe, guiding your mind on a peaceful and meandering journey toward rest. We will imagine the fabric of the universe as a vast silken sheet held in a perfect, silent tension. We will watch as planets and stars create gentle, sloping valleys in this fabric, guiding the paths of moons and light. We will float on the river of time, a river that can slow to a crawl near a massive star or rush forward in the great, empty spaces between the galaxies. We will learn to see gravity not as a force that pulls, but as the simple, effortless act of following the most natural path through a curved and beautiful world. It is a universe far more graceful and interconnected than we ever thought, a place of quiet, flowing geometry. And just before we begin our gentle drift, if you find that these quiet explorations help you to unwind and find your peace, you might consider subscribing. There is no need to do anything now, it is just a soft thought. It simply helps others who are searching for a calm harbor like this to find their way here as well, joining our community of quiet wanderers. But for now, your only task is to let go. You do not need to follow every word, and you certainly don't need to remember anything. If your mind wanders, that is perfectly fine. Let it drift like a cloud on a gentle breeze. If you fall asleep, that is the best thing of all. My voice is simply here to be a soft anchor for your awareness, a steady, quiet rhythm in the background. So close your eyes, breathe deeply, and let the journey begin. There is an invisible fabric to the universe, a silent and underlying reality known as spacetime. We cannot see it or touch it, yet it is as real as the floor beneath you, as tangible as the air in this room. Imagine a vast, infinitely large sheet of the softest, darkest silk stretched perfectly taut in every direction, filling the quiet void of the cosmos. This is the stage upon which everything unfolds, but it is not a passive backdrop. This fabric is a dynamic and responsive landscape, the very substance of existence. Every single thing that has mass, from the smallest fleck of dust to the most ancient and colossal galaxy, rests upon this material and is held by it, supported by it, and connected through it. The universe does not simply exist within this space, the universe is this flowing, bending, and curving fabric. It is the context for every star that shines, every planet that turns, and every quiet moment that passes. Every object with mass, from a distant star to your own body, creates a gentle indentation in this cosmic fabric. Think once more of that vast, silken sheet of spacetime stretching out into the quiet darkness. If you were to place a heavy, smooth stone in its center, the silk would sag downwards, creating a gentle, sloping curve around the weight. In exactly this way, the immense mass of our sun creates a vast and sloping valley in the fabric of spacetime, a gravitational well that defines our entire solar system. The Earth, being so much smaller, creates a more modest dip, a gentle dimple resting within the larger valley created by the sun. And even you, resting here now, create your own infinitesimally small, almost imperceptible depression in this universal material. Your very presence has a shape in this unseen dimension, a quiet and profound signature written into the geometry of the cosmos. 3. Gravity is not an invisible force that pulls, but is simply the shape of the world you are in. We have always imagined gravity as an unseen rope, tethering the moon to the earth or pulling a falling leaf to the ground. But in this more graceful understanding, there is no pull at all. Imagine a tiny marble rolling across that stretched, silken sheet of spacetime. If the sheet is perfectly flat, the marble will travel in a perfectly straight line forever. But if a heavier ball rests in the center, creating a deep curve, the marble's path will naturally bend as it follows the slope of the indentation. The marble is still attempting to move in a straight line, but the very ground beneath it is curved, guiding its path into a gentle, looping orbit. The Earth is not being pulled by the sun, it is simply following the straightest possible path through the curved spacetime the sun has created. It is a silent cosmic ballet choreographed by the geometry of reality itself. 4. Space and time are not separate things, but are two aspects of a single unified whole. For most of human history, we pictured space as a vast, unchanging container and time as a universal clock, ticking at the same rate for everyone, everywhere. Space was the where, and time was the when. But this is not the full picture of reality. The two are deeply and inextricably woven together, like the warp and weft of a single shimmering tapestry. You cannot have one without the other, and you cannot move through one without affecting your journey through the other. To pinpoint any event in the cosmos, from the flicker of a candle to the explosion of a star, you need 4 coordinates. 3 to describe its location in space, and 1 to describe its location in time. This 4-dimensional reality is the true landscape of our universe, a place where space and time are forever bound together. 5. Even while you are lying perfectly still, you are traveling through space-time at an incredible speed. Part of this journey is your movement through space. The Earth is spinning on its axis while simultaneously orbiting the Sun at over 60,000 miles per hour, and the entire solar system is sweeping through the Milky Way galaxy on a vast, slow spiral. But there is another journey you are on, an even more fundamental one, a constant and unstoppable journey through the dimension of time. Every second that passes is a movement forward into the future. Albert Einstein realized that these two kinds of motion, through space and through time, are connected. Your total speed through the 4 dimensions of space-time is always constant, and it is equal to the speed of light. So, as you rest here, nearly still in space, almost your entire budget of motion is being spent on traveling through the dimension of time, carrying you gently from one moment to the next. 6. The Earth follows its orbit around the Sun because it is taking the most natural path available. It feels counterintuitive to us as we see the Earth's orbit as a beautiful looping ellipse. But from the Earth's own perspective, it is doing the simplest thing possible. It is moving straight ahead. Think of an ant walking on the surface of a large, smooth globe. The ant believes it is walking in a perfectly straight line, but if you were to watch it from a distance, you would see it trace a long, graceful curve across the globe's surface. The ant is following the straightest possible path. In exactly the same way, the Earth is moving along its own straightest possible path through the 4-dimensional space-time that has been curved by the Sun's immense mass. It is a planet taking the path of least resistance, a journey of perfect, effortless motion through a silent, invisible landscape. It is an orbit of pure geometry, a perfect circle in a higher dimension. 7. A star far more massive than our Sun warps the spacetime around it like a heavy cannonball on a soft trampoline. Let us return to that gentle image of the stretched fabric of the universe. A star many times heavier than our own Sun would create a depression in spacetime that is incredibly deep and steep-sided. The slope of the curve around it would be immense. Any object, even a beam of light, that passed too close would find its path dramatically altered, bent by the sheer depth of this gravitational well. If the star is massive enough and collapses down into a small enough space, the well it creates can become so deep that its sides are perfectly vertical. It punches a hole in the fabric of reality itself. This is what we call a black hole, a place where the curvature of spacetime becomes infinite, a waterfall of reality from which nothing, not even light, can ever return. 8. The shortest path between 2 points in the cosmos is not always a straight line. In the flat, simple world of classroom geometry, a straight line is always the shortest distance. But the universe is not flat. The presence of stars and galaxies gives it curves and contours, hills and valleys. Just as the shortest path for an airplane flying between 2 cities on our spherical Earth is a long, gentle arc, the shortest path for a spaceship traveling between 2 star systems is a curve that navigates the dips and wells in spacetime. This path, the most efficient and direct route through curved spacetime, is called a geodesic. It is the path that light naturally follows as it travels from a distant star. It is the path the planets follow as they circle the sun. It is the universe showing us that the most direct journey is one that respects the shape of the landscape. 9. This invisible fabric can ripple and wave, like the surface of a still and silent pond. When 2 incredibly massive objects, like 2 black holes or 2 dense neutron stars, spiral into one another and finally merge, the event is so powerful that it shakes the very fabric of spacetime itself. This disturbance does not stay in one place. It spreads outward in all directions at the speed of light, just like the concentric ripples from a single raindrop falling into a still pond. These are gravitational waves. They are not waves through space, but rather waves of space. As they pass by, they gently stretch and compress everything in their path, first in one direction and then the other. The effect is impossibly small, far smaller than the width of a single atom. But with our most sensitive instruments, we have learned to feel these faint, ancient tremors from cosmic collisions that happened billions of years ago. 10. A massive spinning object can twist the fabric of spacetime around with it. Imagine a heavy ball spinning in a large vat of thick, clear honey. As it spun, it would drag the honey around with it, creating a slow, swirling vortex in the otherwise still liquid. In a similar way, a massive, rotating object, like a star or a black hole, doesn't just curve spacetime, it twists it. It grabs hold of the fabric of reality and drags it along in the direction of its spin. This effect is called frame dragging. It means that the very definition of standing still is different near a spinning mass, because spacetime itself is in motion. Any object, even a beam of light, that tries to travel straight past it would be dragged slightly sideways by this cosmic whirlpool. It is a subtle and beautiful confirmation that space is not a passive backdrop, but a dynamic, flowing substance. 11. The simple act of falling is just you following the natural downward slope of spacetime. When you drop a pen or a book, it doesn't fall because of a mysterious pull from the Earth's center. It falls because the immense mass of the Earth has created a significant slope in the spacetime all around it. The object is simply rolling downhill along this invisible incline. An astronaut in orbit feels weightless, not because they have escaped gravity, but because they are in a state of continuous, perfect freefall. They, their spaceship, and everything inside it are all constantly falling together, coasting along the smooth curve of spacetime created by the Earth. That feeling of weightlessness is the feeling of pure, unimpeded motion through the geometry of the universe. The feeling of weight you have right now is simply the bed or chair beneath you pushing up and stopping you from following that natural downward path. 12. Your path through this day has been a unique trajectory through 4 dimensions. From the moment you woke to this very moment of rest, you have been tracing a one-of-a-kind line through the landscape of spacetime. This line is called your world line. It records not only your movement through the three dimensions of space, left and right, forward and back, up and down, but also your constant, unwavering movement forward through the fourth dimension, time. If you could see it from the outside, it would look like a long, intricate thread stretching from your birth into your future. Every person, every planet, every photon of light has its own unique world line, weaving through the great tapestry of reality. The paths may cross and interact, influencing each other's curves with their mass, but each one is a distinct and personal journey through the whole of existence. 13. Time itself flows like a great and silent river, moving faster in some places and slower in others. We experience time as a constant, steady beat, a universal rhythm ticking away at the same rate for everyone, everywhere in the universe. But this is an illusion born of our limited, human-scale perspective. According to relativity, time is fluid and malleable. It can be stretched and compressed by the world around it. In regions of the universe where gravity is very weak, such as in the deep, empty voids between galaxies, the river of time flows very quickly. But near massive objects where gravity is strong, the river slows down, becoming deep and sluggish. Time itself is part of the physical universe, and it is affected by the objects within it. It does not stand apart as a neutral observer. It participates in the cosmic dance. 14. A clock on a high mountaintop ticks ever so slightly faster than a clock at sea level. This is a real and measurable effect of gravity's influence on time. Gravity is slightly weaker at the top of a mountain than it is down in a valley, simply because you are farther from the center of the Earth's mass. Because of this, time flows just a tiny fraction of a second faster at higher altitudes. Scientists have tested this with incredibly precise atomic clocks. They synchronized two of them perfectly, left one at a lower elevation, and flew the other in an airplane for many hours. When the clocks were brought back together again, the one that had been flying high up in weaker gravity was just a little bit ahead of the one that remained on the ground. The difference is minuscule, far too small for any human to ever notice, but it is a profound confirmation that the pace of your own time depends on where you are. 15. As you rest here now, your feet are aging just a little bit more slowly than your head. Because your feet are closer to the center of the Earth than your head is, they are in a slightly stronger gravitational field. The difference is almost unimaginably tiny, but it is real and it is always there. The river of time is flowing a fraction of a second slower at your feet than it is at the crown of your head. Over the course of your entire lifetime, your head will have aged a few nanoseconds more than your feet will have. It is a gentle, persistent reminder that there is no single now for your entire being. Every part of your body is experiencing its own unique local flow of time, dictated by its precise position in the Earth's gentle gravitational field. You are a collection of slightly different timelines, all resting together in perfect harmony. 16. The faster you move through the dimensions of space, the slower you move through the dimension of time. This is the other side of time's malleability, a beautiful effect known as time dilation. It is not just gravity that alters the flow of time, but also motion. As you increase your speed through space, your journey through time must slow down to compensate, as your total motion through space-time remains constant. If you were on a spaceship traveling at 99% of the speed of light, your time would slow down dramatically compared to someone on Earth. You might experience only 1 year passing, watching a single season come and go, but when you returned, you would find that 7 years had passed for everyone you left behind. Your clock, your heartbeat, your thoughts, everything about your personal experience of time would be moving in a beautiful slow motion relative to the rest of the world. 17. For a photon of light, a timeless traveler, the passage of time does not exist. This is one of the most wondrous and peaceful ideas in all of physics. A photon, a single particle of light, travels at the ultimate cosmic speed limit. Because of this, from the photon's own perspective, time comes to a complete and utter standstill. A photon that was born in the heart of a distant star 1 million years ago and traveled across the vast, silent emptiness of space to reach your eye tonight has not aged a single instant. For that photon, its creation and its absorption were the same moment. It experienced its entire journey, 1 million years of our time, as an instantaneous leap across the universe. The beginning and the end of its voyage were one. It is a truly timeless messenger, a particle that does not experience the duration of its own journey. 18. The now you are experiencing is not the same now for someone on a distant star. We have a powerful intuition that there is a single, universal present moment that all beings in the universe share simultaneously. But relativity shows us this comfortable idea cannot be true. Because the speed of light is finite, it takes time for information to travel from one place to another. Imagine a civilization on a planet orbiting Proxima Centauri, our nearest stellar neighbor, about 4 light-years away. The now over there, that is happening at the same time as your now, is something we can never truly know or experience. By the time we could receive any signal from them, 4 years will have passed for us. What we see of them is always their past. The idea of a simultaneous cosmic now is impossible to define, because there is no way for everyone in the universe to agree on what time it is everywhere at once. 19. There is no single universal clock ticking for the entire cosmos. If you could place perfectly accurate clocks on every planet, in every galaxy, you would find that they all tick at different rates. A clock near the edge of a supermassive black hole would be ticking incredibly slowly, almost at a standstill. A clock floating in the empty void between galaxies would be ticking very fast. A clock on a planet moving at high speed would tick slower than one on a planet moving slowly through space. There is no master clock, no central pacemaker for the universe that we can all synchronize to. Time is profoundly local. The only time that you can truly measure and know for certain is your own proper time, the time that is passing for you right here, right now. It is your personal, unique experience of the flow of the cosmic river. 20. The immense gravity of a black hole slows time down to an almost complete stop. As you approach the event horizon of a black hole, the point of no return, the curvature of space-time becomes extreme, and the river of time slows to a mere trickle. If a friend were watching you from a safe distance through a powerful telescope, they would see your image appear to move in slower and slower motion as you got closer to the edge. Your movements would seem to take an eternity. They would see your clock ticking more and more slowly until, as you reached the horizon, it would appear to freeze altogether. From their perspective, it would take an infinite amount of time for you to cross that boundary. For you, however, your own time would feel perfectly normal as you fell across that silent threshold into the unknown. 21. The GPS satellites that orbit the Earth must constantly adjust their clocks to account for time flowing differently for them. This is where the grand cosmic theory of relativity becomes an essential part of our everyday lives. The satellites that make up the global positioning system orbit high above the Earth, where gravity is weaker, so their internal atomic clocks tick slightly faster than clocks on the ground. At the same time, they are moving at very high speeds, which makes their clocks tick slightly slower. The effect of weaker gravity is the more powerful of the two. The net result is that their clocks gain about 38 microseconds every single day. If engineers did not build corrections for this relativistic effect into the system, the GPS would fail. Tiny errors in time would accumulate, causing navigational errors that would grow by miles every single day. 22. The past, present, and future might all exist at once, like different points along a silent, flowing river. This is a philosophical interpretation of relativity, but a powerful and calming one. Because the present moment is not universal, it suggests that what is future for you could be past for an observer moving in a different way. This has led some physicists to imagine a block universe where all of time, every moment that has ever been and ever will be, exists eternally and simultaneously. Time doesn't flow in this view, it just is. Our consciousness simply moves through it, illuminating one moment at a time, creating the illusion of passage. The past is not gone, and the future is not unwritten. They are just other places in the vast four-dimensional landscape of spacetime that we have not yet reached or have already left behind. 23. Simultaneity is relative. Two events happening at the same time for you could happen at different times for someone else. Imagine you are standing in the exact middle of a very long glass-walled train car as it moves smoothly past a station. At the very same moment, a light flashes at the front of the car and another at the back. Because you are in the middle, the light from both flashes reaches your eyes at the same time, and you correctly conclude the flashes were simultaneous. Now, imagine someone standing on the station platform watching the train go by. From their perspective, you are moving towards the light from the front flash, so it reaches you sooner. You are moving away from the light from the back flash, so it reaches you later. They would see the front flash of light reach you first and would correctly conclude the events were not simultaneous. Who is right? You both are. There is no single truth about the timing of events in the universe. 24. Matter is a form of frozen, concentrated energy. We tend to think of matter and energy as two completely different things. Matter is the solid, stable substance of the world, the chair you are in, the ground beneath you. Energy is the active, intangible thing that creates change and motion, light, heat, and sound. But Albert Einstein's most famous equation, E equals mc squared, revealed a deep and profound truth. They are two faces of the same underlying substance. Matter is simply energy that has been slowed down and packed together into a stable form. It is like the relationship between water and ice. Ice is simply water that has settled into a quiet, solid state. In the same way, matter is energy in a state of deep rest. Every object you can touch, every physical thing in the world, is a piece of slumbering, frozen light. 25. A single drop of water holds a quiet, hidden storm of unimaginable energy. The equation, E equals mc squared, tells us exactly how much energy is locked away inside a piece of matter. The E stands for energy, the m for mass, and the c squared is the speed of light squared. Because the speed of light is such an enormous number, and it is squared on top of that, the formula tells us that even a tiny amount of mass is equivalent to a staggering amount of energy. The mass contained in a single grain of sand, if it could be converted entirely into energy, would be enough to power a home for years. This vast, dormant potential rests quietly within every object around you, a silent testament to the immense power bound up in the very substance of the world. The universe is far more potent than it appears to the eye. 26. The sun shines by converting its own mass directly into light and heat. For centuries, the source of the sun's incredible power was a deep mystery. What could possibly burn so brightly for so many billions of years? The answer lies in the equivalence of mass and energy. In the sun's incredibly hot and dense core, under immense pressure, hydrogen atoms are fused together to create helium. This process, called nuclear fusion, is not perfectly efficient. The resulting helium atom has slightly less mass than the hydrogen atoms that went into making it. This tiny amount of missing mass has not vanished. It has been converted directly into a tremendous burst of energy in the form of photons of light and heat. This is the energy that pushes its way out of the sun's core and radiates out into space, warming our planet and making all of life possible. 27. Every single second, the sun transforms 4 million tons of its matter into pure energy. Let that number settle in your mind. 4 million tons. Every second that passes, a mass equivalent to a great mountain is annihilated in the heart of the sun and reborn as the radiant energy that floods our solar system. It is a rate of conversion that is almost impossible to comprehend. And yet, the sun is so incomprehensibly vast that it has been doing this for 4.5 billion years, and it has enough fuel in its core to continue for another 5 billion more. It is a slow, steady, and colossal act of transformation. The light that warms your face during the day is the ghost of matter that no longer exists, a message from the heart of a star that is constantly sacrificing a tiny part of its own substance to illuminate its family of worlds. 28. The atoms that make up your body contain a vast and dormant power. Consider the carbon, oxygen, and hydrogen atoms that constitute your being. Each one is a tiny, self-contained reservoir of bound energy. The forces that hold the protons and neutrons together in the nucleus of each atom are incredibly strong, and they represent a huge amount of stored energy. If you could take a single gram of the matter in your body and convert it entirely to energy, the release would be more powerful than the largest conventional bombs ever created. It is a humbling and peaceful thought that this quiet, stable-seeming physical form we inhabit is, at its most fundamental level, a vessel of such immense and unimaginable power, held in a state of perfect, peaceful balance. You are a temporary sculpture made of contained starlight. 29. The speed of light in a vacuum is the ultimate speed limit of the universe. In the entire cosmos, there appears to be a fundamental rule of the road, a barrier that nothing with mass can ever surpass. That speed is the speed of light, traveling through the emptiness of space at approximately 186,282 miles per second. It is a cosmic constant, a fundamental property of our universe. It is not just a limit for light itself, but for everything. No object, no piece of information, no causal influence can travel faster than this speed. It is woven into the very relationship between space and time. This ultimate velocity is the highest gear of the universe, and only massless things, like the photons of light themselves, are permitted to use it. It is the universe's most profound and unbreakable law. 30. The speed of light is the same for you, no matter how fast you are already moving. This is the strange and beautiful idea upon which all of special relativity is built, and it defies all of our everyday logic. Normally, if you are driving in a car at 50 miles per hour and you throw a ball forward, someone on the sidewalk would see the ball moving at its own speed plus the 50 miles per hour of the car. But light does not behave this way. If you were on a spaceship moving at half the speed of light and you turned on a flashlight, the light beam would still move away from you at the speed of light. And for someone watching you fly past, they would also measure that beam of light moving at the exact same speed. To make this strange fact true, the universe must bend everything else, your experience of time and your measurement of space, to ensure this one rule is never, ever broken. Starlight can be bent by the gravity of a massive galaxy, like a lens bending light. Imagine holding up the thick, curved base of an old glass bottle and looking through it at a distant candle flame. The curved glass would bend the light from the candle, distorting its image, perhaps even making it appear in several places at once. In the cosmos, a massive galaxy or a cluster of galaxies can do the exact same thing. Its immense gravity creates such a deep and powerful curve in the fabric of spacetime that it acts as a natural cosmic lens. When the light from an even more distant object, like a young galaxy, passes through this curved region, its path is bent and guided. We on Earth can then see this light, which would have otherwise missed us completely, guided towards our telescopes by gravity's gentle and silent hand. 32. Sometimes, astronomers see multiple images of the same distant galaxy, its light split by gravity's lens. The effect of this gravitational lensing can be quite dramatic and beautiful. If the alignment is just right, with a distant object, a lensing galaxy, and the Earth all in a perfect line, the light can be bent in such a way that it creates multiple images of the same single object. Astronomers might look into their telescopes and see 2 or even 4 identical copies of a distant galaxy, arranged in a pattern around a central massive one. They are not 4 different objects, but 4 different paths that the light from a single object has taken to us, like taking different roads around a mountain to arrive at the same village. Each path has a slightly different length, meaning the light from one image might arrive months or even years before the light from another. It is like seeing echoes of light, all from the same ancient source. 33. You are always seeing the past, as light takes time to travel from an object to your eyes. The speed of light, while immense, is not infinite. This means that every single thing you see is a delayed image, a ghost of a moment that has already passed. For things in the same room, this delay is only a few billionths of a second, completely imperceptible. But as we look further out, the delay becomes profound. The image you see of the moon is from 1.3 seconds ago. The warm light from the sun that reaches us is from over 8 minutes in the past. If the sun were to suddenly vanish, we would not know about it for 8 full minutes. Every glance up at the night sky is an act of gentle time travel. You are not seeing the stars as they are now, but as they were when they first sent their ancient light on its long and silent journey across the void. 34. Looking at the Andromeda galaxy is like looking 2.5 million years into the past. Andromeda is the most distant object that can typically be seen with the naked eye, appearing as a faint, fuzzy smudge of light in the autumn sky. That faint, ethereal glow began its journey long before modern humans walked the Earth. It has been traveling through the cold, dark void between galaxies for 2.5 million years. The photons striking your retina tonight left Andromeda when our distant ancestors were just beginning their own journey on the plains of Africa. What we see is a galactic ghost, a portrait of our nearest major cosmic neighbor as it was in a deep and ancient past. We can have no knowledge of what is happening in the Andromeda galaxy now. We can only wait for another 2.5 million years for that news to arrive. 35. Gravity can change the color of light, gently stretching it into a deeper red. Light can be thought of as a wave, with peaks and troughs like ripples on water. The color of the light depends on the distance between these peaks, which is its wavelength. As a beam of light climbs out of a deep gravitational well, like that of a massive star, it has to expend energy to escape. This loss of energy does not make the light slow down. It always travels at the same constant speed, but it does make the light waves stretch out. The distance between its peaks gets longer. This stretching shifts the light towards the red end of the spectrum, a phenomenon called gravitational redshift. Light that falls into a gravitational field experiences the opposite effect, gaining energy and shifting towards the blue. Gravity gently repaints the light that passes through its domain. 36. The path of a beam of light is a map of the curves in spacetime. Because light is such a faithful traveler, following the contours of spacetime with perfect precision, it becomes our greatest tool for mapping the invisible structure of the universe. By observing how the images of distant galaxies are distorted and warped, astronomers can reconstruct the shape of the spacetime between us and them. They can map the locations of vast, unseen clumps of a mysterious substance called dark matter, whose gravity is responsible for most of the lensing effect we observe. It is a form of cosmic cartography, using the light from the most ancient objects in the universe as the ink to draw a map of the hidden structures that dominate the cosmos. We are learning to read the gentle bends in starlight as if they were contour lines on a map of reality itself. 37. This cosmic speed limit is what holds the law of cause and effect together. The fact that nothing can travel faster than light is not just a frustrating limitation for cosmic travel, it is the essential glue of a logical universe. It ensures that an effect can never happen before its cause. Imagine if you could send a signal faster than light. You could send a message back in time to yourself, telling yourself the result of a lottery before it is drawn. The universal speed limit of light protects the timeline from such paradoxes. It defines a clear and absolute boundary between the past and the future for any given event. It means the universe unfolds in a coherent, orderly fashion where the past influences the present and the present influences the future in a one-way, gentle flow of causality. 38. The starlight you see tonight has been traveling through the quiet void for hundreds or thousands of years. Consider a single bright star in the night sky. The light that graces your eye tonight from that star began its journey long before anyone alive today was born. It has been traveling across the immense, silent gulf of space ever since, through all the intervening centuries of human history. That light is older than the house you live in, older than the town you live in. For all those hundreds of years, it has been silently and faithfully crossing the immense distance, a solitary messenger on a vast and lonely road. And tonight, at the very end of its long, long journey, it finds its final destination with you. All the stars in the sky tell a similar story of patient, ancient travel, a story that ends in this quiet moment. 39. A twin who travels to the stars at high speed will return younger than the twin who stayed on Earth. This is the famous twin paradox, a thought experiment that makes the consequences of time dilation very clear and personal. Imagine two identical twins. One stays on Earth, living a normal life, while the other embarks on a long, fast journey to a distant star and back. For the traveling twin, their personal clock ticks more slowly due to their high speed relative to Earth. When they finally return home, they will have aged less than the twin who remained behind. The stay-at-home twin might be 80 years old, their hair turned to silver, while the traveling twin steps from the spaceship still only 40 years old. This isn't a paradox, but a real consequence of their different paths through spacetime. Two different journeys can lead to two different ages. 40. Heavy objects create deep, slow-moving pools in the river of time. This disturbance radiates outward, not as sound or light, but as waves in the very structure of reality. When they finally merge, a single, tremendous burst of these gravitational waves is released. For a fraction of a second, the energy released is greater than the light from all the stars in the observable universe combined, yet it is all released in perfect, profound silence. 43. These gravitational waves stretch and squeeze everything they pass through, including you, right now. As these ripples of spacetime wash over the Earth, they have a subtle physical effect. They are waves that cause a distortion perpendicular to their direction of travel. As a wave passes through you, it would first stretch you very slightly in one direction while squeezing you in the other, and then, a moment later, it would do the opposite. The effect is impossibly small. For the first gravitational wave ever detected, the amount of stretching and squeezing was 1,000 times smaller than the nucleus of a single atom. You would never, ever feel it. But our most sensitive instruments, great L-shaped detectors with lasers bouncing down long tunnels, can detect this infinitesimal cosmic breath as it passes. For over 1 billion years, these waves traveled across the universe to finally wash over us. The first gravitational wave signal that was successfully detected in 2015 came from a truly ancient and distant event. It was the merger of two black holes that were each about 30 times the mass of our Sun. The collision happened in a distant, unnamed galaxy about 1.3 billion light-years away from us. This means the waves themselves had been traveling through intergalactic space for 1.3 billion years. When they were first created, the most complex life on Earth was still single-celled organisms floating in the ancient oceans. The waves have been journeying through space ever since, silently carrying the story of that cataclysmic merger until they finally washed over our planet and into our detectors, delivering their billion-year-old news. 45. A black hole is not an object, but a place where space-time itself is falling inward. We often think of a black hole as a dark, solid thing that sits in space, but a more accurate and wondrous way to imagine it is as a region of space that is itself in constant one-way motion. Think of a wide, calm river that suddenly narrows and flows over a huge, invisible waterfall. The water itself is flowing, and once it passes a certain point, the edge of the falls, it cannot flow back up. A black hole is like this, but with the fabric of spacetime itself. The mass of the collapsed star has curved spacetime so extremely that it creates an inward flowing current. The event horizon is the point of no return, where the current of space is flowing inward faster than the speed of light. 46. At the center of a black hole, our understanding of space and time comes to a gentle end. According to the theory of general relativity, all the matter that falls into a black hole is crushed down into an infinitely small, infinitely dense point at the very center. This point is called a singularity. At a singularity, the laws of physics as we currently understand them break down completely. The curvature of spacetime becomes infinite. Density becomes infinite. Our concepts of when and where lose their meaning. It is a place where the two great pillars of modern physics, general relativity and quantum mechanics, give conflicting answers about the nature of reality. The true nature of the singularity is one of the deepest unsolved mysteries in science, a place where the universe is hiding a secret we have not yet deciphered. 47. We cannot see a black hole, but we can see the stars that dance around the emptiness where it sits. Since black holes themselves emit no light, we must find them through their effects on the things around them. One of the most common ways is to watch the motion of nearby stars. At the very center of our own Milky Way galaxy, astronomers have spent decades tracking the orbits of a small cluster of stars. These stars are moving at incredible speeds, whipping around a single central point that is completely dark and invisible. By measuring their orbits, scientists can calculate that they must be circling an object with a mass of over 4 million suns, all packed into a space smaller than our solar system. The only thing that could possibly be that massive and that dark is a supermassive black hole, the quiet anchor of our galaxy. 48. The sound of two black holes merging is a quiet chirp in the symphony of spacetime. When we convert the signal of a gravitational wave into an audible sound that we can hear, it has a distinct and beautiful character. As the two black holes spiral closer and closer, they orbit faster and faster. This causes the frequency of the gravitational waves they emit to increase and their amplitude to grow. The resulting sound starts as a low rumble and then rapidly rises in pitch and volume over the course of a few seconds, ending in a final, sharp chirp at the exact moment of merger. It is a sound that has been traveling for 1 billion years, a sound made by the flexing of spacetime itself. It is the universe's own unique voice, and we are just now learning how to hear its strange and wonderful music. 49. Einstein imagined these waves a century before we were able to detect them. 100 years before the LIGO detectors felt that first faint tremor from a distant black hole merger, Albert Einstein, working with only a pen, paper, and his own profound intuition, predicted that these waves must exist. His theory of general relativity, his new description of gravity, implied that massive, accelerating objects would create these ripples in the fabric of spacetime. For a century, they remained a beautiful but unproven theoretical consequence. The waves were thought to be so incredibly faint, so impossibly difficult to detect, that many doubted we ever would. The eventual detection was a monumental triumph, a testament to human ingenuity and the incredible predictive power of a truly beautiful idea about the nature of our universe. 50. Listening to gravitational waves is like listening to the silent echoes of creation. For all of human history, our knowledge of the universe has come from studying light. We have used our eyes and then telescopes to look at the electromagnetic radiation coming from stars and galaxies. But this is like experiencing the world using only one of our senses. Gravitational waves have opened up a completely new way for us to perceive the cosmos. We are no longer just looking at the universe, we are now listening to it. We are listening to the vibrations caused by its most hidden and violent events, the collision of black holes, the merging of neutron stars. It is a new sense, allowing us to perceive the dark, silent side of the universe, the side that emits no light at all. We have grown a new ear to hear the whispers of the void. 51. The entire universe is expanding, carrying galaxies away from each other on a gentle cosmic tide. This is the grandest stage on which relativity plays out. On the largest scales, we observe that almost all galaxies are moving away from us, and the farther away a galaxy is, the faster it appears to recede. This is not because of a great explosion that sent everything flying outwards from a central point. It is because the fabric of spacetime itself is stretching, growing, and creating more distance between things. Imagine a loaf of raisin bread rising in a warm oven. As the dough expands, it carries all the raisins along with it. From the perspective of any one raisin, all the other raisins are moving away, and the more distant ones are moving away faster. This is our universe. We are on one of the raisins, in a gentle, cosmic leavening. It is a slow, silent, and universal breath taken by the cosmos itself. 52. It is not that galaxies are moving through space, but that space itself is stretching between them. This is a subtle but deeply peaceful distinction. The galaxies themselves are not flying through space like cosmic projectiles. Most of them are relatively stationary within their own local patch of spacetime, like islands in a great ocean. But the ocean itself is growing, and its currents are creating more distance between the islands. This is why some distant galaxies can be receding from us faster than the speed of light. This does not violate the cosmic speed limit, because that limit applies to motion through space. The galaxies are not traveling through space faster than light. It is the space between us and them that is expanding at that incredible rate. The map of the universe is being gently redrawn, moment by moment. 53. The light from distant galaxies is stretched by this expansion, becoming redder as it travels to us. This cosmological redshift is different from the Doppler shift caused by an object moving through space. It is a direct consequence of the stretching of space-time itself. As a photon of light travels across billions of light years from a distant galaxy, the space it is traveling through is constantly expanding beneath it. This expansion gently stretches the wavelength of the photon along with it, just as a wave drawn on a rubber sheet would stretch if you pulled on the sheet. A photon that was emitted as brilliant, high-energy blue light will arrive here as soft, low-energy red light. The amount of this stretching is a direct measure of how much the universe has expanded during the photon's long and lonely journey. The light itself becomes a ruler, measuring the growth of the universe. 54. There is a profound connection between gravity and acceleration that feels like a hidden symmetry. Albert Einstein had a thought he called his happiest. A person in a closed room, like an elevator, could not tell the difference between being at rest on Earth, feeling the pull of gravity, and being in deep space, accelerating upwards at a constant rate. In both cases, they would feel the same sensation of weight. A dropped ball would fall to the floor in the exact same way. This is the principle of equivalence. It suggests that the force we feel as gravity and the force we feel from acceleration are, at a fundamental level, two aspects of the same phenomenon. It was this deep insight that allowed Einstein to generalize his theory from the special case of constant motion to the grand, universal picture that includes gravity. Gravity is simply the feeling of being held still in an accelerating world. 55. The feeling of weight you experience is the force of the world accelerating up to meet you. This is another way to understand the principle of equivalence. Imagine you are in a state of perfect, natural freefall, following a geodesic through spacetime. In this state, you feel perfectly weightless. The sensation of weight only appears when something stops your fall. The ground beneath you is preventing you from following that natural path. In a sense, every point on the surface of the Earth is constantly accelerating outwards, pushing against the natural inward curve of spacetime. The weight you feel is the pressure of the ground resisting your natural motion. It is a beautiful reversal of our intuition. You are not being pulled down, the world is constantly rushing up to hold you in place. A wormhole is a theoretical and gentle bridge through the fabric of spacetime. Within the beautiful mathematics of general relativity, there exist intriguing and speculative solutions to the equations. One of these is the concept of an Einstein-Rosen bridge, which has come to be known as a wormhole. It is a hypothetical shortcut, a tunnel that could connect two very distant points in space, or even two different moments in time. Imagine taking a large sheet of paper, marking two distant points on it, and then folding the paper over so the 2 points touch. A wormhole is the theoretical three-dimensional equivalent of punching a hole through that fold, creating a path that is much shorter than traveling the long way around on the surface. It is a gentle fold in the map of reality, a whisper of a hidden passage. 57. The equations of relativity allow for the possibility of these cosmic tunnels, but they remain a beautiful dream. It is important to remember that while the mathematics of relativity permits wormholes to exist, we have never seen one, and we have no evidence that they are a real feature of our universe. The equations that describe them also suggest they would be incredibly unstable. Most known types of wormholes would collapse in on themselves the instant anything, even a single photon of light, tried to pass through them. To hold one open might require a form of exotic matter with strange properties, like negative energy, which may not exist in nature. For now, they remain a beautiful and fascinating possibility, a ghost that haunts the elegant equations of spacetime. They are a dream the universe is having, written in the language of mathematics. 58. A journey through a wormhole could be a journey through space, or a journey through time. Because space and time are so deeply intertwined in the fabric of spacetime, a tunnel through this fabric could connect not just different places, but different times as well. A wormhole could, in theory, connect the present day with a moment 1,000 years in the future or 1,000 years in the past. This, of course, raises all sorts of complex paradoxes about causality and changing history. This is another reason many physicists believe that some unknown principle of nature must prevent such things from forming. But their possibility reminds us that the landscape of spacetime is a rich and mysterious place, with features that still challenge the very limits of our understanding and imagination. It is a whisper of the possibility of touching the past or the future. 59. The cosmic expansion is not slowing down, it is gently and mysteriously speeding up. For many decades, astronomers assumed that the expansion of the universe, which began with the Big Bang, must be gradually slowing down due to the mutual gravitational pull of all the galaxies on each other. They expected to find that the rate of expansion was less today than it was in the past. But in the late 1990s, observations of distant supernovae revealed the exact opposite. The expansion of the universe is accelerating. Something is pushing spacetime apart, a gentle but persistent pressure that is overcoming the pull of gravity on the largest scales. This mysterious influence was given a name, but not an explanation: dark energy. It is a quiet, invisible, and ever-present force woven into the very vacuum of space itself. Dark energy is like a soft, constant anti-gravity inherent in the fabric of space itself. This mysterious energy does not seem to come from any particular source. It is not radiated by stars or galaxies. Instead, it appears to be a property of empty space itself. As the universe expands and more empty space is created, more of this dark energy comes into being, which in turn pushes the expansion to go even faster. It is a quiet, cosmic feedback loop. While gravity works to pull things together, forming stars and galaxies, dark energy works on the vast scales between the galaxies, gently pushing them further and further apart. It is the silent, unseen counterpart to gravity, a force of expansion rather than contraction. It is the long, slow, deep exhalation of the cosmos. 61. The fate of our universe seems to be one of endless, quiet expansion into a cold, dark future. If this accelerating expansion driven by dark energy continues, it points to a specific and perhaps lonely end for our cosmos. As the eons pass, the galaxies will be pushed further and further away from each other. One by one, they will recede over the cosmic horizon, their light so redshifted that it becomes undetectable. Eventually, our own Milky Way galaxy will be left as a single, isolated island in a vast, empty, and dark universe. The night sky of the far future will be almost completely black, with no other galaxies visible. It is a peaceful, if somber, vision of a universe slowly fading into a quiet and gentle sleep, its energy spread ever more thinly across an ever-growing expanse. 62. Every path you take is a geodesic, the straightest possible line on a curved surface. Let us return to the idea of the most natural path. In a curved spacetime, a geodesic is the route that a free-floating object will naturally follow. It is the path of a planet in orbit, the path of a photon of light from a distant star, and the path of a thrown ball here on Earth. All of these objects are simply coasting, following the path of least resistance through their local geometric landscape. Our own lives are a series of constrained geodesics. When we walk, drive, or fly, we are following the straightest possible path allowed by the surface of the Earth and the choices we make. All motion in the universe is a form of this quiet surrender to the easiest and most natural path available. 63. A spinning star drags the very fabric of space-time around with it, like a spoon stirring thick honey. We have touched on this idea before, but let us rest with its strange beauty. When a massive object spins on its axis, it does not just sit in a static dimple in spacetime. Its rotation actively twists the spacetime in its immediate vicinity. The effect, called frame dragging, means that space-time itself is pulled into a gentle, swirling vortex around the spinning object. This has been measured by incredibly sensitive gyroscopes in orbit around our own Earth. Our planet's gentle rotation subtly stirs the reality in its neighborhood, a silent and invisible whirlpool that affects the path of everything that passes through it. The rotation of a planet is subtly written into the shape of the space around it. 64. Near a rapidly spinning black hole, space-time is dragged so intensely you could not stand still even if you tried. This effect of frame dragging becomes incredibly powerful near a dense, rapidly rotating black hole. There is a region outside the event horizon called the ergosphere. Within this region, space-time is being dragged around the black hole faster than the speed of light. This does not mean things are traveling through space faster than light, but that space itself is moving that fast. Because of this, it would be physically impossible to remain stationary from the perspective of a distant observer. Even with the most powerful rockets firing against the current, you would be forced to move in the direction of the black hole's spin. It is a place where the river of space-time has become a violent, inescapable whirlpool. 65. A white hole is the theoretical, time-reversed opposite of a black hole. Just as the mathematics of relativity describes black holes, from which nothing can ever escape, it also allows for their perfect mirror image, white holes. A white hole would be a region of spacetime from which things can escape, but into which nothing can ever enter. It would be a source that spews out matter and energy, but is causally disconnected from its past. You could never trace a path back into it. Like wormholes, there is no evidence that white holes exist in our universe. They may be a purely mathematical curiosity, a phantom born from the symmetries of the equations. Some have speculated that the Big Bang itself might have been something like a white hole, a singular event from which everything in our universe emerged as if from a cosmic fountain. 66. The orbit of Mercury, the innermost planet, is a beautiful and subtle proof of curved spacetime. For centuries, astronomers were puzzled by the orbit of Mercury. Its elliptical path around the Sun is not perfectly stable. The whole ellipse slowly rotates or precesses over time. Newtonian gravity could account for most of this precession due to the gravitational tug of the other planets, but there was a tiny, stubborn discrepancy left over that no one could explain. General relativity solved the mystery perfectly. Mercury is the closest planet to the Sun and orbits in the deepest, most curved part of its gravitational well. The precise shape of that curve in spacetime, as predicted by Einstein's equations, accounts for the missing part of its precession exactly. Even the smallest planets feel the deep truth of the universe's shape. 67. There is an invisible scaffolding to the universe, made of a substance we cannot see. When astronomers observe the rotation of galaxies, they see something strange. The stars on the outer edges are moving far too fast. According to our understanding of gravity, they should be flung off into intergalactic space. The visible matter in the galaxy, the stars, gas, and dust, does not have enough gravity to hold them in their orbits. To account for this, scientists have proposed the existence of dark matter. It is a mysterious, invisible substance that does not emit or reflect any light, but which has gravity. It is thought to form a vast, spherical halo around every galaxy, a great, unseen cloud of matter whose gentle, collective gravity holds the spinning city of stars together. 68. Dark matter acts as the silent, gravitational anchor for the cosmos we see. This invisible substance is not a minor component of the universe. Current estimates suggest that dark matter outweighs all the normal, visible matter by a factor of more than 5 to 1. It is the dominant gravitational influence in the cosmos. It formed the first great cosmic structures, creating vast filaments and clumps into which normal matter later fell, forming the galaxies and galaxy clusters we observe today. It is the invisible skeleton of the universe, the hidden framework upon which the luminous beauty of the cosmos is built. We cannot see it, but we can infer its presence by its gentle, persistent gravitational pull on the things we can see. 69. We are drifting through a vast, invisible sea of dark matter right now. Our own solar system, as it orbits the center of the Milky Way, is constantly moving through the great halo of dark matter that surrounds our galaxy. Billions of these mysterious particles are likely passing through your body and through the entire Earth every single second. But they interact so weakly with normal matter that they pass through it as if it were a ghost. They do not bump into our atoms or affect us in any discernible way, other than through their collective gravity on a galactic scale. We live and breathe and sleep inside a vast, silent cloud of an unknown substance, a quiet and invisible component of our cosmic home. 70. The universe described by relativity is far stranger and more wonderful than we can truly imagine. As we wander through these ideas, of time that flows like a river, of space that can bend and ripple and twist, of matter that is frozen energy, of unseen matter and unknown energies, it becomes clear that the reality we inhabit is a place of profound mystery and awe. The world of our everyday intuition, with its solid objects and steady, universal flow of time, is just a simplified sliver of the whole magnificent picture. The underlying reality is a dynamic, fluid, and magical-seeming place that continues to surprise and delight us the deeper we look. It is a universe that is not only stranger than we imagine, but perhaps stranger than we are capable of imagining. 71. The golden ring of a gravitationally lensed galaxy is sometimes called an Einstein ring. When the alignment of a distant galaxy, a lensing galaxy, and our own planet is absolutely perfect, the light from the background galaxy can be smeared and stretched into a perfect glowing circle around the foreground one. This beautiful and rare phenomenon is called an Einstein ring. It is a cosmic bullseye, a perfect projection of the deep symmetry of the gravitational lens. Finding one is like seeing the universe achieve a moment of perfect accidental artistry. It is a testament to the fact that the strange, warping effects of gravity can, under the right circumstances, create objects of profound and simple beauty, painting a perfect circle of ancient light in the dark canvas of the night sky. 72. The theory is tested every time you use your phone's map to find your way home. Let us end our cosmic journey with the most practical and immediate connection. The global positioning system in your phone relies on a network of satellites, each with a very precise atomic clock. To calculate your position, the system needs to compare the timing of signals from several of these satellites. But as we know, the clocks on those satellites tick at a different rate from clocks on the ground due to the effects of both special and general relativity. Without applying the precise corrections predicted by Einstein's theories, the entire GPS system would fail within minutes, accumulating errors of several miles every single day. This grand cosmic theory is what keeps you from getting lost on the way home. 73. The simple elegance of these ideas has reshaped our view of everything. The journey from a clockwork universe of invisible poles and forces to a geometric universe of graceful curves and currents is one of the greatest intellectual journeys humanity has ever taken. It replaced a mechanical view with a more organic one, a rigid view with a fluid one. It showed us that the fundamental components of our reality, space and time, are not the fixed and absolute background we assumed them to be. They are pliable, personal, and profoundly intertwined. This new view has given us a deeper and far more beautiful understanding of the cosmos and our quiet, gentle place within its vastness. It is a story that turned the universe from a machine into a poem. 74. From the smallest particle to the largest galaxy, all are adrift on the currents of spacetime. Let this be a unifying, peaceful thought. The electron orbiting an atom, the moon orbiting a planet, the star orbiting a galactic core, the galaxy cluster drifting on the tide of cosmic expansion, all are subject to the same gentle guidance from the same underlying fabric. They are all following the contours of the same universal landscape. There is a deep unity in all of this motion. Everything is simply finding its own unique path through the same shared reality. All of the complexity and diversity of the cosmos stems from this one single principle, playing out on different scales in different places. Everything is floating, together in the same invisible ocean. 75. The mystery of relativity is the mystery of the shape of the universe itself. At its heart, this entire journey has been an exploration of geometry. It is a theory about the shape of reality and how that shape affects everything within it. It is a story of lines, curves, surfaces, and dimensions. It invites us to think about our universe not as a collection of things, but as a single, four-dimensional form with its own unique and evolving shape. The deepest questions that remain, what is dark matter? What is dark energy? What happens inside a black hole? Are all, in essence, questions about the true and complete geometry of our cosmos. We are all inhabitants of a beautiful, mysterious, and unseen shape. 76. We are travelers on a small planet, following a gentle curve around our home star. Let your awareness settle here, in this simple, local truth. You are resting on the surface of a sphere called Earth. This sphere is currently moving along a great elliptical path, a geodesic, through the curved spacetime created by the Sun. It is a journey of hundreds of millions of miles, completed once every year, and it is a journey of perfect, weightless freefall. We do not feel the motion because we and the atmosphere and everything around us are all falling together in perfect, harmonious unison. It is a calm, stable, and predictable journey that has been going on for billions of years. You are on a gentle, cosmic carousel, turning slowly in the quiet darkness of space. Our star is following a wider, more majestic curve around the center of our galaxy. Now zoom out once more with your mind. Our Sun, with its entire family of planets in tow, is not stationary. It is on an even grander orbit, a slow, majestic sweep around the supermassive black hole at the heart of the Milky Way galaxy. This journey takes over 200 million years to complete just one circuit. The last time our solar system was in this position in its orbit, dinosaurs were just beginning to walk the Earth. We are all participating in this vast, silent, and ancient spiral, a flowing river of 100 billion stars, all following the deep and powerful curve in spacetime created by our galaxy's immense collective mass. We are drifting in a great, starry river on a slow journey to nowhere in particular. 78. And our galaxy itself is drifting on the slow expanding tide of the universe. And finally, our entire Milky Way galaxy, this vast island of stars, is itself not fixed in place. It is being carried along on the great outward flow of cosmic expansion. Along with our neighboring galaxy Andromeda and a few dozen smaller ones, we are moving through the universe as a small, gravitationally bound family. But the space between our local group and other, more distant galaxy clusters is constantly growing. We are adrift on the largest and most gentle current of all, the deep, underlying expansion of spacetime itself, a tide that carries everything along with it on its silent, patient journey. We are like a single boat in a fleet of billions on an ever-widening, peaceful ocean. 79. It is all one great, silent, interconnected dance of geometry and matter, from the tiny dimple in spacetime created by your own resting body to the vast curve that guides our galaxy through the void. It is all part of a single, unified system. Everything affects everything else in this graceful cosmic choreography. The motion of the planets, the shining of the stars, the expansion of the cosmos, and the flow of time in this very room are all different expressions of the same underlying dance between matter, energy, and the geometry of spacetime. It is a dance of quiet elegance, of profound simplicity, and of deep, interconnected beauty. You are a resting, breathing part of this silent, cosmic performance. And you are a quiet, resting part of this cosmic drift. So let your awareness come to rest here, in this moment. Feel your body held gently by the small, local curve of the Earth. Feel your breath moving in the quiet, local flow of time. You are a part of this great, drifting universe. You are made of stardust, subject to the same gentle laws that guide the galaxies in their silent turning. There is no separation. You belong here. You are a way that the cosmos has become aware of itself for a brief and wonderful moment. And now it is time for that awareness to soften, to dissolve into a quiet and peaceful rest. You are a child of the cosmos, safely at home in the quiet of the night. 81. The universe does not have an edge, just as the surface of a sphere has no edge. This is a strange but calming idea that relativity helps us to understand. When we think of the expanding universe, we might imagine it expanding into a pre-existing emptiness. But the universe is not expanding into anything. It is all there is. It could be that the three-dimensional space of our universe is curved back on itself in a higher, fourth spatial dimension, much like the two-dimensional surface of a sphere is curved in the third dimension. If this were the case, you could travel in a straight line in any direction and, after an unimaginably long journey, eventually end up right back where you started. In such a universe, there is no edge and no center. It is finite, yet unbounded. 82. Energy can be borrowed from the vacuum of space for a fleeting moment. This is a place where relativity touches the strange world of quantum mechanics. The vacuum of empty space is not truly empty. It is shimmering with a constant fizz of virtual particles that pop in and out of existence in moments too brief to measure. These particles can appear, along with their antiparticle partners, by briefly borrowing energy from the universe, as long as they repay the debt by annihilating each other almost instantly. This quantum foam is happening everywhere, all the time, even in the space inside the atoms of your own body. It is a deep, underlying restlessness to the fabric of reality, a silent, shimmering energy that permeates all of existence. 83. Near a black hole's horizon, these borrowed particles can become real. Stephen Hawking realized that if a pair of these virtual particles were to pop into existence right at the edge of a black hole's event horizon, it's possible that one could fall in while the other escapes. The particle that escapes can no longer annihilate with its partner, so it becomes a real particle. To conserve energy, the black hole must pay the debt for its creation, and it does so by giving up a tiny fraction of its own mass. This slow, steady emission of particles is known as Hawking radiation. It means that over immense, almost unimaginable timescales, black holes can slowly evaporate, radiating their mass back into the universe as a faint thermal glow. Even the darkest things in the universe can eventually dissolve into light. 84. The information about what falls into a black hole may be stored on its surface. A deep puzzle in physics is what happens to the information of an object that falls into a black hole. Is it destroyed forever in the singularity? Some physicists, using a concept called the holographic principle, believe the information is not lost. They suggest that all the information about the three-dimensional interior of the black hole is encoded on its two-dimensional surface, the event horizon, like a cosmic hologram. As the black hole evaporates via Hawking radiation, this information is slowly and subtly encoded into the escaping particles, eventually returning to the universe. In this view, nothing is ever truly lost, only scrambled and stored in a different form. The universe may be a perfect record keeper, never losing a single bit of its story. 85. Our universe may be one of countless others in a vast cosmic multiverse. While purely speculative, some theories that try to unite relativity and quantum mechanics suggest that our universe may not be the only one. The process that created our Big Bang could be common, with new universes constantly budding off from others, each with potentially different physical laws and constants. This collection of universes is often called the multiverse. In this grand vision, our cosmos, with its beautiful laws of relativity and its specific conditions for life, is just one bubble in a vast, infinite foam of other realities. It is a humbling and wondrous thought that our entire known existence might be just one page in an infinite library of possible worlds. 86. The search for a single, elegant theory to describe everything is the great quest of modern physics. Albert Einstein spent the last decades of his life on a search for a unified field theory, a single set of equations that could describe both gravity and electromagnetism as aspects of one underlying reality. He did not succeed, but that dream continues today. Physicists are now trying to unite general relativity, our best theory of the very large, with quantum mechanics, our best theory of the very small. These two pillars of modern physics are incredibly successful in their own domains, but they give conflicting answers in extreme situations, like the center of a black hole or the first instant of the Big Bang. The search for a theory of everything is the search for a deeper, simpler truth from which both of these beautiful theories emerge. 87. String theory imagines that all particles are tiny, vibrating loops of energy. One of the most prominent candidates for a theory of everything is string theory. It proposes that the fundamental constituents of the universe are not point-like particles, but unimaginably small, one-dimensional strings of energy. Each string vibrates at a different frequency, and these different vibrational modes are what we perceive as different particles: an electron, a photon, a quark. In this view, the entire rich diversity of the universe is like the music of a grand cosmic orchestra, all played on these tiny fundamental strings. Gravity itself emerges naturally from this framework as a specific vibration of a closed loop of string. It is a beautiful and mathematically elegant idea that attempts to unify all forces and all matter into a single harmonious picture. 88. A gravitational wave passes through you as if you were made of glass. Unlike light or sound, gravitational waves interact incredibly weakly with matter. A ripple of spacetime can travel from a distant galaxy, pass through entire stars and planets, and then pass through the entire Earth and your own body almost completely unimpeded. This is why they are so difficult to detect, but it is also what makes them such pure messengers. They carry an unaltered story of their cataclysmic origins, a message that has not been blurred or blocked by anything it encountered on its billion-year journey. They are the cleanest possible window into the most extreme events the universe has to offer. They are whispers from the void, arriving here as clear as the day they were first spoken. 89. The first image of a black hole was not a photograph, but a portrait painted with radio waves. In 2019, the Event Horizon Telescope collaboration released the first ever direct image of a black hole silhouette. It was not taken with a single telescope, but by a network of radio telescopes scattered all across the globe, all working in perfect unison. By combining their data, they created a virtual telescope the size of the Earth itself, with enough resolving power to see the shadow of the supermassive black hole at the center of the M87 galaxy, 55 million light-years away. The image shows a dark central region, the shadow cast by the event horizon, surrounded by a glowing ring of superheated gas, its light bent by the black hole's immense gravity. It was a beautiful, visual confirmation of a reality once only imagined in equations. 90. The universe is not just beautiful, but it is beautiful in a way that can be understood. One of the most profound and mysterious things about our universe is that it is comprehensible. The same elegant mathematical principles that can be written down on a piece of paper seem to describe the grand workings of the cosmos with incredible accuracy. There is no obvious reason why this should be so. The universe did not have to be governed by simple, discoverable laws. The fact that it is, and that our minds are capable of discovering and understanding them, is perhaps the greatest wonder of all. The story of relativity is a testament to this deep and calming connection between our own quiet thoughts and the silent, majestic turning of the cosmos. 91. Your personal experience of time is your own unique journey through the fourth dimension. Let us bring our awareness back to this personal, quiet truth. The time that is passing for you right now as you listen to these words is your proper time. It is a real, physical quantity, a measure of the distance you have traveled along your own unique world line since you were born. It is your personal timeline, and its pace is subtly influenced by every movement you make and every change in altitude you experience. It is your own private river, flowing at its own unique rate. While all our rivers flow in the same direction, toward the future, each one has its own local currents and eddies. There are as many different experiences of time in the universe as there are observers to feel it. 92. The force we call gravity is simply the feeling of the world preventing our most natural motion. Think one more time about the feeling of weight. It is not a pull from below. It is a push from below. You are in a gravitational field, which means you are on a slope in spacetime. Your natural, effortless tendency is to follow that slope downhill. The bed or chair beneath you is simply a barrier, an obstacle that is stopping you from taking that path of least resistance. The feeling of pressure, of weight, is the feeling of that barrier pushing against your body. An astronaut in orbit feels no such push, and so they are weightless, because they are free to follow their natural path without obstruction. Weight is the feeling of being held back from a state of perfect, peaceful freefall. 93. Einstein's theory is a story of the universe's quiet, underlying simplicity. Beneath all the immense complexity we see, the swirling galaxies, the burning stars, the diversity of life, the laws of relativity suggest a universe built on principles of profound elegance and simplicity. The idea that all motion is just objects following the straightest possible path. The idea that matter and energy are two forms of the same thing. The idea that space and time are a single, dynamic entity. It is a theory that constantly reveals a simpler, more unified reality hiding just beneath the surface of our perceptions. It invites us to look for the simple, beautiful patterns that govern the whole of existence. The cosmos may be vast and complex, but its fundamental rules are a gentle, whispered poem. 94. Relativity tells us that the universe is a story that is still being written. Because information cannot travel faster than light, our knowledge of the universe is always limited to our past light cone, the collection of all events in the past whose light has had time to reach us. The universe beyond that horizon is, for now, unknowable to us. As time passes, the light from more distant events will finally reach us, expanding our knowledge and revealing more of the cosmic story. Our understanding of the universe is constantly growing, not just because our telescopes get better, but because the universe itself is slowly revealing more of its history to us, one ancient photon at a time. We are living within an unfolding revelation. 95. The final test of a great theory is its beauty and simplicity. Einstein himself was often guided by a deep sense of aesthetic judgment. He believed that the correct laws of nature must be mathematically beautiful and simple. His theory of general relativity is considered by many scientists to be the most beautiful physical theory ever conceived. It is a compact set of equations that can describe the entire universe, from the fall of an apple to the dawn of time, with breathtaking accuracy. Its ability to explain so much with so little is a source of deep wonder. It suggests that, at its most fundamental level, the universe operates on principles of pure and simple elegance, a truth that can be as calming and reassuring as it is profound. 96. Every object in the universe is on a journey of pure, effortless motion. Let this be a final, restful image. From the smallest particle to the largest supercluster of galaxies, nothing is truly straining or struggling. Everything is simply following the most natural path available to it, a path of least resistance carved into the geometry of spacetime. A planet in orbit is not fighting the pull of the sun. It is coasting in a state of perfect balance. A photon of light is not forcing its way through the void. It is following the straightest possible road. There is a deep, abiding peace in this picture of the universe. It is a cosmos not of conflict and forces, but of quiet surrender to the graceful, flowing shape of the world. 97. The universe is a great, silent sculpture made of space and time. If you could step outside of it all and perceive the four dimensions at once, you might see the entirety of the cosmos, from the Big Bang to the distant future, as a single, static object. It would be an unimaginably complex sculpture, with the world lines of every particle, planet, and star forming intricate, intertwined patterns within it. There would be great troughs and canyons carved by galaxies, and tiny little dimples from planets and people. Our experience of the flow of time is simply our consciousness moving through this sculpture, experiencing one slice of it at a time, from one moment to the next. But the entire sculpture, the whole of spacetime, might simply be, all at once, in a timeless, peaceful existence. 98. All the laws of physics are the same for you no matter how you are moving. This was the first simple postulate from which Einstein began his journey. It is a principle of deep democracy for the universe. It means there is no privileged observer, no special vantage point from which the true reality can be seen. The laws of nature are equally valid for someone resting on Earth, someone on a spaceship traveling at near light speed, or someone in a distant galaxy. The universe presents a slightly different face to every observer. Measurements of time and distance will change, but the underlying rules of the game are the same for all players. It is a universe with one set of laws, accessible and true for everyone, everywhere. 99. The theory of relativity is, at its heart, a love story about space and time. Before Einstein, space and time were seen as separate, independent entities, living in the same house but rarely interacting. Relativity revealed that they are profoundly and inextricably in love, bound together into a single, inseparable whole called spacetime. They dance together, influencing each other in every moment. The way an object moves through space determines how it experiences time. The presence of mass tells spacetime how to curve, and that curvature tells matter how to move. It is a story of a deep and fundamental connection, a unity at the heart of reality that makes the universe a far more graceful and cohesive place than we ever knew. 100. The same laws that shape the stars shape your own quiet rest. As we come to a pause in our journey, let your mind settle on this final connection. The principles that we have been exploring are not distant or abstract. The gentle curve of spacetime is holding you in your bed. The steady, personal flow of time is carrying you from this moment to the next. The equivalence of mass and energy is slumbering in every atom of your being. You are a part of this grand geometric dance. You are a child of this flowing, relativistic universe. And all of its strange and beautiful laws are conspiring in this quiet moment to bring you peace, to bring you stillness, and to guide you gently into a deep and profound sleep. 101. For every event that occurs in the universe, there is a boundary of cause and effect known as its light cone. Imagine an event, like the flicker of a candle, happening at a single point in spacetime. The future light cone is the expanding bubble of all the places that the light from that candle flicker can possibly reach in the future. Nothing can travel faster than that expanding bubble of light, so nothing outside of that cone can ever be affected by the candle's flicker. The past light cone is the inverse, a cone stretching back in time that contains all the events that could have possibly influenced the candle's flicker. This beautiful geometric structure is the universe's way of enforcing causality. It creates a clear and absolute distinction between a personal past, a personal future, and a vast, inaccessible elsewhere that you can neither affect nor be affected by in this moment. It is the gentle, luminous architecture of cause and effect. The universe as a whole has a shape, a grand geometry that we are trying to measure. On the largest of scales, the fabric of spacetime could have one of three possible forms. It could be perfectly flat, like an infinite sheet of paper, where parallel lines will stay parallel forever. It could have a positive curvature, like the surface of a great four-dimensional sphere, where parallel lines would eventually meet. Or it could have a negative curvature, like the surface of a vast cosmic saddle, where parallel lines would drift ever further apart. Our current measurements suggest the universe is remarkably, almost perfectly flat. This implies a cosmos that is infinite in extent, a vast and endless plane of spacetime. It is a peaceful thought that we might live in a universe of infinite space, a gentle and boundless landscape for the galaxies to drift within. 103. The oldest light in the universe is a gentle, invisible glow that surrounds us in every direction. It is called the cosmic microwave background. This light is the faint, ancient afterglow of the Big Bang itself. It was released about 380,000 years after the beginning, when the universe first cooled enough for atoms to form and for light to travel freely through space. In that moment, the entire cosmos was filled with a brilliant, uniform golden light, like the inside of a star. But in the 13.8 billion years since, the expansion of the universe has stretched this ancient light, lengthening its wavelengths from visible light into the cool, low-energy microwaves we detect today. When you look at a map of this radiation, you are seeing a baby picture of the universe, the very first light, now faded into a quiet, cosmic whisper. 104. The Big Bang was not an explosion in space, but an expansion of space itself. We often imagine a single point of fire and energy exploding into a pre-existing empty void, but this is not the picture relativity paints. There was no outside for the universe to expand into. The Big Bang happened everywhere at once. Every single point in our observable universe was once part of that initial, incredibly hot and dense state. The expansion was the creation of space, the stretching of the fabric of spacetime itself. The distance between all points began to grow, and it is a process that continues to this day. It is a more peaceful and profound image, not a violent detonation, but the gentle and continuous unfolding of space and time from a single, unified beginning. 105. There are special states of motion called inertial frames, which are states of pure, effortless coasting. An inertial frame of reference is the perspective of an observer who is not accelerating, who is moving at a constant velocity through space. An astronaut floating in a spaceship with its engines off, far from any planet, is in an inertial frame. A ball rolling on a perfectly frictionless surface is in an inertial frame. These are the calmest, most natural states of motion in the universe. It is within these peaceful, coasting frames that the laws of physics take on their simplest and most elegant form. Relativity begins with the idea that these states of effortless motion are the fundamental baseline of reality, and that the laws of nature should appear the same to everyone who is lucky enough to be in one of these quiet, drifting states. 106. The principle of relativity states that the laws of physics are the same for all who are gently coasting. This is the simple, powerful, and democratic heart of Einstein's theory. It means there is no experiment you could perform inside a closed, smoothly moving room that could tell you whether you are at rest or moving at a constant velocity. The swing of a pendulum, the flight of a paper airplane, the ripple in a glass of water, all would behave in exactly the same way. There is no absolute rest in the universe. All non-accelerated motion is relative. This simple idea, when combined with the constant speed of light, leads to all the strange and wonderful consequences of relativity. It is a universe where the fundamental rules are the same for every traveler on a smooth and steady journey. 107. Gravity communicates its presence across the void in perfect and profound silence. All the other forces we know communicate through the exchange of particles, but gravity is different. It is the shape of the world. A change in that shape, such as the merger of two black holes, propagates outward not as a particle, but as a ripple in the fabric of reality itself. These gravitational waves travel at the speed of light, but they are not a form of light. They are a disturbance of pure geometry, a message written in the language of distance and time. It is the most fundamental form of communication in the universe, and it is completely silent. The greatest cosmic storms, events that release more energy than all the stars combined, unfold without a sound, their story told only in the quiet, gentle flexing of spacetime. 108. The entire history of the universe is written in the stretching of ancient light. As the universe expands, it leaves a clear and readable signature on the light that travels through it. The further away a galaxy is, the longer its light has been traveling to reach us, and therefore the more the universe has expanded during its journey. This means the amount of redshift we see in a galaxy's light is a direct measure of its distance, and also a measure of the cosmic time when that light was emitted. Astronomers can use this relationship to piece together the entire history of cosmic expansion. They can see how the expansion rate has changed over the eons, slowing down in the early universe due to gravity, and now speeding up due to dark energy. The light itself is a cosmic historian, its fading color telling the story of the universe's long and patient growth. Near a black hole, gravity is so strong that even light can be trapped in an orbit. Just outside the event horizon of a black hole, there is a region called the photon sphere. At this precise distance, the curvature of spacetime is so extreme that a photon of light can be forced to travel in a circular path. A beam of light could orbit the black hole forever, like a tiny luminous moon.
If you were able to stand on this photon sphere and look straight ahead, you would see the back of your own head, as the light from it would have traveled all the way around the black hole to return to your eyes. It is a place of perfect but unstable balance, a shimmering ring of captured light, a final, beautiful halo around the edge of the abyss, forever circling the darkness but never falling in. 110. On cosmic scales, the gentle pull of gravity is the most powerful and inevitable force of all. While gravity is the weakest of the four fundamental forces on a small scale, over vast distances and immense timescales, it is the undisputed architect of the cosmos. It is the force that patiently gathers wisps of hydrogen gas into brilliant stars. It is the force that organizes those stars into the vast swirling cities we call galaxies. And it is the force that pulls those galaxies together into great clusters and superclusters, the largest structures in the known universe. Gravity is a force of infinite patience. Given enough time, its gentle, persistent whisper can move mountains, build worlds, and shape the entire destiny of the cosmos. It is the silent, organizing principle of the material world. 111. The universe can be imagined as a great four-dimensional river of unfolding events. This is the block universe idea expressed in a different, more fluid way. Imagine a river where every drop of water is an event in spacetime. From our perspective within the river, we are carried along by the current, experiencing one moment after another as the flow of time.
We cannot see the parts of the river that are behind us, in the past, or the parts that are ahead of us, in the future. But from a viewpoint on the riverbank, outside of time, the entire river, from its source at the Big Bang to its eventual end, could be seen all at once. The entire history of the cosmos exists as a single, flowing, but complete entity. Our lives are a small, gentle eddy in this immense and timeless cosmic river. 112. The vacuum of empty space is filled with a quiet, simmering energy. Relativity and quantum mechanics both tell us that empty space is not truly nothing. It is a dynamic medium with physical properties. According to quantum theory, it is filled with a sea of virtual particles, a quantum foam of fleeting existence. According to relativity, this vacuum energy, also called dark energy, has a small, persistent pressure that is causing the universe to expand at an accelerating rate. This energy of the void is the most mysterious and abundant form of energy in the cosmos, making up nearly 70% of everything that is. The vast emptiness between the stars is not empty at all, but is filled with a silent, invisible, and powerful substance that is shaping the ultimate fate of our universe. 113. Time travel to the past seems to be gently forbidden by the laws of our universe. While the equations of relativity might seem to allow for exotic possibilities, like wormholes that could lead to the past, most physicists believe that nature has a quiet way of preventing paradoxes. One idea is the chronology protection conjecture, which suggests that the laws of physics themselves conspire to prevent time travel from ever happening on a macroscopic scale. Perhaps any attempt to create a time machine would cause it to self-destruct in a burst of energy, or perhaps the wormholes required are simply impossible to create or stabilize. The universe seems to cherish its own history, protecting the gentle, one-way flow of cause and effect from being rewritten. The past is a country we can view from afar but never revisit. 114. The search for quantum gravity is a quest to unite the worlds of the very large and the very small. We have two magnificent theories of the universe. General relativity describes the smooth, curving, large-scale world of gravity, stars, and galaxies. Quantum mechanics describes the fuzzy, probabilistic, small-scale world of particles and forces. The great challenge of modern physics is to find a single, deeper theory that can unite them. We need a theory of quantum gravity to understand the most extreme environments in the cosmos, like the singularity at the heart of a black hole, or the very first moment of the Big Bang, where the universe was both incredibly massive and incredibly small. The search for this theory is the search for the universe's ultimate, most fundamental secret. 115. One alternate vision imagines that space itself is made of tiny, discrete, and indivisible loops. While string theory imagines particles as vibrating strings, a different approach to quantum gravity, called loop quantum gravity, takes another path. It suggests that the fabric of spacetime is not a smooth, continuous sheet, but is woven from a network of finite, quantized loops. Space is not infinitely divisible. If you could zoom in to an impossibly small scale, you would find that space itself is made of tiny, indivisible atoms of geometry. Time, too, would not flow smoothly, but would tick forward in discrete, indivisible steps. In this view, the universe is like a shimmering, pointillist painting, its smooth appearance emerging from a vast collection of tiny, fundamental dots of reality. 116. The universe is a perfect democracy. There is no special or privileged place within it. This is a core idea in modern cosmology known as the cosmological principle. It states that on the largest scales, the universe is the same everywhere. There is no center and no edge. An observer in a galaxy a billion light-years away would see a universe that looks, on average, exactly the same as the one we see. They would see galaxies receding from them in all directions, just as we do. This principle is a final and profound extension of the Copernican idea that we are not in a special, central place. It paints a picture of a universe that is vast, uniform, and fundamentally the same for all its inhabitants, no matter where they happen to call home. 117. The gentle pull of the moon on the Earth's oceans is a visible stretching of spacetime. The phenomenon of the tides is a beautiful, large-scale demonstration of gravity as geometry. The moon's mass creates its own gentle curve in the spacetime around it. The part of the Earth closest to the moon is in a slightly more curved region than the center of the Earth, so it is pulled along its geodesic path a little more. The part of the Earth farthest from the moon is in a less curved region, so it gets left behind a little. The Earth itself is rigid and holds its shape, but the fluid oceans are free to respond to this differential stretching of spacetime. They bulge outwards on both the side facing the moon and the side facing away, creating the two high tides we see each day. The tides are the shape of the ocean, conforming to the gentle, invisible shape of the world. 118. The feeling of freefall is the feeling of being perfectly aligned with the universe's geometry. It is the state of pure, natural motion. When an astronaut floats weightlessly in orbit, or when you feel that momentary lightness as a car goes over the crest of a hill, you are experiencing what it is like to move without resistance along a geodesic path. In that moment, you are in perfect harmony with the local shape of spacetime. It is a feeling of deep peace, of effortless coasting. It is the universe's baseline state, the way things move when nothing is pushing against them. All other sensations of force and weight are the feeling of being deflected from this natural, graceful, and silent path. Weightlessness is the feeling of coming home to the universe's most fundamental state of being. 119. All of the boundless complexity of the cosmos emerges from a few simple and elegant rules. This is one of the most reassuring truths revealed by physics. The universe, with its billions of galaxies, its burning stars, its swirling nebulae, and its intricate forms of life, is not a chaotic and arbitrary place. It all seems to operate according to a handful of profound and often simple underlying principles, like those described by relativity. The universe has a deep, hidden order. This suggests that the complexity we see is not a sign of chaos, but a testament to the incredible richness that can arise from letting a few simple, elegant rules play out over vast scales of space and time. It is a universe of emergent beauty, born from a core of perfect, quiet simplicity. 120. The future is not a place we are going to, but a direction in the landscape of spacetime. In the four-dimensional world of relativity, time is a direction, just like forward or up. We are all on a constant, unstoppable journey in the future direction. We cannot stop this journey, nor can we turn around. This constant motion through time is a fundamental property of our existence as beings with mass. The present moment is simply the location of our consciousness along this temporal axis. The future is the territory ahead of us on the map, a landscape that already exists in the block universe view, which we are steadily moving towards. It is a calming thought that our journey is not a frantic race, but a steady, predictable, and shared movement in a single, fundamental direction. 121. The deep past is a place we can see, but a shore we can never return to. The finite speed of light gives us a remarkable gift, a window into the past. When we look at a distant galaxy, we are seeing it as it was billions of years ago. We are, in a very real sense, looking at the past. The further we look, the earlier in cosmic history we can see. We can watch galaxies forming, see the first stars ignite, and even glimpse the faint afterglow of the Big Bang itself. But this is a one-way window. We are passive observers of this ancient history. We can receive these messages from the past, these postcards of light, but we can never travel there ourselves to touch that ancient shore. The past is a museum we can visit with our telescopes, but never with our bodies. 122. Relativity gives a new and deeper meaning to the ideas of here and now. Before relativity, here was a simple point in space, and now was a universal moment in time. But in a four-dimensional spacetime, here and now is a single unified concept, an event. It is a specific point, a unique address, in the great four-dimensional landscape. Your here and now is different from the here and now of someone on the moon, or someone in a distant galaxy. Each of us is at the center of our own personal perception of the universe, a unique origin point from which we view the rest of spacetime. It is a deeply personal and local view, a quiet understanding that my reality is defined by my own specific place and my own specific time. The world would appear shorter and slower to a traveler moving at a very high speed. Let us imagine being on a spaceship traveling past the Earth at 90% of the speed of light. From your perspective, looking out the window, the Earth would appear squashed in the direction of your motion. It would look like a flattened sphere. This is length contraction. At the same time, you would observe everything on Earth happening in a beautiful slow motion. You would see clocks on Earth ticking more slowly than your own, people moving as if through water. This is time dilation. For you, everything is normal, but the world you are passing appears warped in both space and time. It is a reminder that there is no single objective reality, only a collection of different perspectives, each one equally valid from its own point of view. 124. The universe has a perfect memory, written in the light of distant stars. Nothing in the universe is ever truly instantaneous. Every event, from a supernova explosion to a conversation between friends, sends out light that travels into the cosmos forever. That light carries the information of that event with it, encoded in its properties. In principle, a sufficiently advanced civilization far in the future could collect that light and reconstruct the event, watching it unfold as if it were happening right now. In this sense, the universe never forgets anything. Every moment is preserved, broadcast into the void as a sphere of light that expands for eternity. The cosmos is a great library of past moments, its stories all written in faint, ancient, and ever-receding light. 125. The quiet stability of our solar system is a testament to the predictability of these laws. For billions of years, the Earth has followed its gentle, elliptical path around the Sun. The seasons have come and gone in a steady rhythm. The length of the day has remained almost constant. This remarkable stability, which allowed for the slow, patient evolution of life, is a direct consequence of the elegant and unchanging laws of general relativity. The shape of the sun's gravitational well is stable, and the Earth follows its geodesic path within it with perfect, predictable fidelity. We live in a cosmos where the rules are consistent and reliable. We are held in a gentle, gravitational embrace that is as dependable as it is powerful, allowing us to rest in the safety of a predictable and orderly world. 126. The universe is mostly empty space, but this space is a dynamic physical thing. When we look at the cosmos, we see bright points of light, stars and galaxies, separated by vast gulfs of darkness. It is tempting to think of this darkness as nothing, but relativity teaches us that this empty space is a very real something. It is the fabric of spacetime itself. It can be curved by mass, it can ripple with gravitational waves, it can be twisted by a spinning star, and it can expand, carrying the galaxies along with it. This space is filled with a mysterious dark energy. The emptiness of the universe is not a passive void, but an active and dynamic player in the cosmic story, a substance with its own profound and mysterious properties. 127. There is a quiet and profound power in a single, beautiful idea to change our view of everything. The story of relativity began in the mind of one person, with a few simple questions about light and motion. Yet from that humble beginning grew a completely new vision of the universe. It was a vision so powerful that it reshaped our understanding of the most fundamental things we know: space, time, matter, energy, and gravity. It is a testament to the incredible power of human curiosity and imagination. It shows that by looking deeply and honestly at the world, by following a thought with courage and persistence, we can uncover the most beautiful and hidden truths about the cosmos. A single, quiet thought can be powerful enough to move the universe. 128. Gravity is the weakest of the fundamental forces, yet it is the one that shapes the entire cosmos. On the scale of atoms, gravity is almost laughably weak compared to the electromagnetic and nuclear forces that hold things together. The electrical repulsion between two protons is vastly more powerful than their gravitational attraction. Yet, on the scale of planets and stars and galaxies, gravity is the only force that matters. This is because gravity is always attractive, and it has an infinite range. While other forces can cancel each other out, gravity always adds up. Over cosmic distances and with immense collections of mass, its gentle, persistent whisper becomes a commanding roar, building all the great structures we see in the night sky. 129. The mass of the sun holds our world in a gentle, predictable, and life-giving embrace. The sun's immense gravity creates the stable, gentle curve in spacetime that our Earth has been following for over 4 billion years. This orbit keeps us at a perfect distance, not too hot and not too cold, allowing liquid water to exist and for life to flourish. The sun's gravity is not a violent cage, but a nurturing cradle. It is a constant and reliable presence that has provided the stability necessary for the long, slow, and beautiful story of evolution to unfold on our planet. We are here because we live in a quiet and stable gravitational neighborhood, held in a perfect, life-sustaining balance by the gentle, silent hand of our nearest star. 130. A merger of two black holes is the universe ringing like a bell. When a massive star collapses, it creates a black hole, an object so dense it is like a permanent, silent scar in spacetime. But when two of these objects collide and merge, something remarkable happens. For a brief moment, the newly formed larger black hole is distorted and unstable. To settle into its final, perfect spherical shape, it radiates away the imperfections as powerful gravitational waves. This process is called the ring down. It is as if the collision has struck the very fabric of spacetime, causing it to vibrate and ring like a bell, sending out a clear, decaying tone of pure geometry that travels across the cosmos. It is the sound of spacetime itself, settling back into a state of quiet peace. 131. Every star is a slow, controlled explosion, held in a state of perfect balance by the gentle hand of gravity. The heart of a star like our Sun is a place of unimaginable violence. It is a continuous nuclear fusion bomb, converting hydrogen to helium with explosive force. This outward-pushing pressure from the fusion is constantly trying to tear the star apart, but at the same time, the star's own immense gravity is constantly trying to crush it down into a single point. A star is a place where these two colossal forces have reached a state of perfect equilibrium. The outward push of the explosion is perfectly balanced by the inward pull of gravity. A star is a testament to this perfect, delicate balance, a quiet and stable truth that can last for billions of years. 132. The concepts of up and down are purely local, a product of our planet's gentle curve. On the surface of the Earth, down is simply the direction that points along the steepest slope of our local spacetime curvature, towards the center of the planet's mass. Up is the direction away from it. But in the wider universe, these concepts have no meaning. For an astronaut floating in space, there is no up and no down. Every direction is equal. Our most fundamental sense of orientation is a local phenomenon, a relationship we have with the specific mass of our home world. It is a quiet reminder that our perspective is shaped by our environment, and that the universe at large is a place of profound and beautiful symmetry with no preferred direction. 133. The cosmos is a story of beautiful structures forming from the gentle pull of gravity over eons. In the early universe, matter was spread out in a nearly uniform, smooth fog, but there were tiny, almost imperceptible variations in density. Over hundreds of millions of years, gravity, in its patient and persistent way, began to act on these small imperfections. The slightly denser regions began to gently pull in more matter, becoming denser still. This slow gravitational collapse is what formed the first stars. Those stars then gathered into the first small galaxies, and those galaxies merged and grew over billions of years to create the vast, beautiful, and intricate cosmic web of structures we see today. The entire visible universe is a monument to the quiet, patient, and creative power of gravity. 134. We are made of atoms that have followed these same cosmic rules for 13.8 billion years. The carbon, oxygen, and iron atoms that make up your body were not created on Earth. They were forged in the hearts of stars that lived and died long before our sun was born. These atoms were then scattered into space, where they drifted for eons, all the while obeying the gentle laws of relativity. They followed the curves of space-time around other stars, were gathered by gravity into new clouds of gas, and eventually became part of the nebula that formed our solar system and our planet. The very substance of your being has been on a long and ancient journey through the cosmos, a journey guided at every step by the same elegant and unchanging laws that we have been exploring tonight. 135. There is a deep peacefulness in knowing we are part of a vast, orderly, and understandable system. The universe, as described by relativity, is not a place of random chaos. It is a cosmos that follows elegant, predictable, and discoverable laws. There is a deep, underlying order to its grandeur. This knowledge can be a source of profound comfort and peace. It suggests that we are not adrift in a meaningless void, but are part of a coherent and rational system. The fact that we can understand these laws, that our minds are in some way tuned to the logic of the cosmos, is a beautiful and reassuring mystery. We live in a universe that makes sense, and there is a deep and quiet rest to be found in that simple truth. 136. A journey near a black hole is a journey deep into the future of the universe. The extreme time dilation near a black hole's event horizon creates the ultimate time machine. Imagine a spaceship that could orbit a supermassive black hole for what feels like just 1 year to the crew, because time for them would be flowing so much more slowly than for the rest of the universe. When they finally left their orbit and returned to their home galaxy, they might find that millions of years had passed. They would have taken a one-way trip into the distant cosmic future. This isn't just science fiction. It is a real and profound consequence of the way gravity bends the flow of time. A black hole is a gateway, a place where one can quietly wait as the eons of the universe unfold in a blur. 137. The Great Cosmic Web of Galaxies is a map of the gentlest valleys in the landscape of primordial spacetime. If you map the positions of millions of galaxies, you will find they are not scattered randomly. They are arranged in a vast, beautiful, web-like structure of long filaments and dense clusters separated by enormous, almost empty voids. This structure is a direct echo of the tiny quantum fluctuations that existed in the very first moments after the Big Bang. These tiny variations in density were stretched by cosmic inflation, creating a vast, invisible landscape of shallow gravitational valleys. Over billions of years, dark matter and then normal matter have been slowly rolling downhill into these valleys, creating the luminous, web-like pattern of galaxies we see today. The entire universe is a map of its own quiet beginnings. 138. Dark energy is a gentle whisper of acceleration, a force of persistent, silent growth. The discovery that the universe's expansion is speeding up is one of the most profound and mysterious in all of science. This dark energy is not a violent, explosive force. It is a very weak, very gentle, but utterly persistent pressure that is inherent in the vacuum of space itself. Its effect is unnoticeable on the scale of a solar system or even a galaxy where gravity easily wins. But over the vast, empty distances between galaxy clusters, this tiny, constant push adds up. It is the quiet, dominant energy of the cosmos, a silent and invisible breath that is slowly and gently pushing the universe apart, shaping its long-term future. 149. The universe is not a cold clockwork machine, but a growing, flowing, organic whole. The picture of the universe given to us by relativity is one of dynamism and life. It is not a static stage on which events play out, but an active participant in its own story. Space-time can bend, stretch, ripple, and twist. The universe is expanding, and that expansion is accelerating. New space is constantly coming into being. It is a far more organic and interconnected picture than the old mechanical view of a clockwork cosmos. It feels more like a vast, growing garden than a sterile machine. We are inhabitants of a living, evolving reality, a place of constant, gentle, and profound transformation. 140. The light from the Big Bang has been stretched by a factor of over 1,000 into faint, cool microwaves. The cosmic microwave background radiation was emitted when the universe was about 3,000 degrees Celsius, a brilliant orange-white light. Today, 13.8 billion years later, we detect it at a temperature of just 2.7 degrees above absolute zero. This incredible cooling is a direct result of the expansion of space. As the universe has expanded by a factor of about 1,100 since that time, the wavelengths of those ancient photons of light have been stretched by the exact same factor. This stretching has reduced their energy, transforming them from visible light into the faint, cold microwaves that fill the universe today. The temperature of the cosmos is a direct measure of its age and its growth. 141. The curvature of space in the room around you is too gentle to ever feel. While we have talked about the immense curves created by stars and galaxies, it is calming to remember how subtle gravity is in our own environment. The mass of the entire Earth creates a curvature in space-time that is real, but incredibly gentle. The deviation from a perfectly flat Euclidean geometry is far too small for us to ever notice. Parallel lines do eventually meet, but only after circling the globe. The quiet, gentle nature of gravity in our daily lives is what makes our world feel so stable and predictable. We are living on the calm, flat plains of the cosmic landscape, far from the steep mountains and deep canyons of black holes and neutron stars. 142. A spinning neutron star is a cosmic lighthouse whose beam is dragged by the twisting of spacetime. A pulsar is a rapidly rotating neutron star that emits beams of radiation from its magnetic poles. As the star spins, these beams sweep across the cosmos, and if one happens to sweep across the Earth, we see a regular, pulsing signal. These stars are not only incredibly dense, but they are also spinning incredibly fast, sometimes hundreds of times per second. This rapid rotation creates a powerful frame-dragging effect, twisting the space-time around the star into a powerful vortex. This twisting can affect the path of the radiation beams themselves, and by carefully measuring the timing of the pulses, astronomers can study this strange and beautiful effect of space-time being stirred like a thick fluid. 143. Time is a deeply personal journey, measured not by a universal clock, but by your own quiet rhythm. Let this be a final, personal thought on the nature of time. Relativity teaches us, but there is no master clock, no single beat that the entire universe marches to. The only time that is truly real is your own proper time, the time measured by your own body, your own consciousness. Your life is a journey of a certain length along your own world line, a path with its own unique duration. It is a profoundly intimate and personal experience of the cosmos. As you drift now towards sleep, you are following your own quiet current in the great river of time, a current that is yours and yours alone. 144. The equations of general relativity are like a short and beautiful poem describing the shape of reality. The entire, vast, and complex theory of general relativity can be summarized in a single, elegant equation. This equation, though complex in its mathematical language, expresses a beautifully simple idea. The curvature of spacetime on one side of the equation is set by the presence of matter and energy on the other. It is a cosmic conversation. The universe tells spacetime how to curve, and spacetime tells the universe how to move. That this single, short statement can describe everything from the fall of a leaf to the expansion of the entire cosmos is one of the most profound achievements of the human mind. It is a poem that contains the whole universe in a single line. 145. We see the entire universe through a small, clear window made of ancient light. Our entire perception of the cosmos, every image of a distant galaxy, every measurement of a faraway star, is brought to us by photons of light that have traveled for eons across the void. Light is our sole messenger from the distant universe. It is a faithful, if slow, messenger, carrying its story across unimaginable distances. This means our view of the universe is always a view into the past, but it is also a testament to the clarity of the cosmos. For billions of years, this light has traveled almost unimpeded through the vacuum of space, arriving here with its message intact. The universe is a place that is transparent enough for its own stories to be told. 146. Gravity is the silent, patient architect of the universe, building stars and galaxies from cosmic dust. Imagine the state of the universe long ago, a vast, thin, and almost featureless cloud of hydrogen and helium gas. It was gravity and gravity alone that transformed this simple beginning into the rich and complex cosmos we see today. It patiently gathered the gas into the first stars, then organized those stars into galaxies. It sculpted the great filaments and voids of the cosmic web. All the structure, all the beauty, all the homes for life that exist in the universe are monuments built by this one, simple, persistent, and creative force. Gravity is the universe's master sculptor, working slowly and silently over billions of years to shape the raw material of the cosmos into forms of breathtaking beauty. 147. The universe is a self-creating system, its matter shaping the very space that guides it. This is the beautiful feedback loop at the heart of general relativity. Matter and energy tell spacetime how to curve, creating the gravitational landscape of hills and valleys. In turn, this curved spacetime tells matter and energy how to move, guiding them along its contours. It is a deep and constant conversation, a dynamic dance of co-creation. The universe is not a static object with fixed rules, but a system that is constantly defining itself. The actors on the stage are simultaneously building and shaping the stage itself. It is a holistic and interconnected vision of a cosmos that is perpetually whispering itself into existence. 148. The sublime beauty of a theory that can be tested by the faint light of a distant star. One of the first great confirmations of general relativity came during a solar eclipse in 1919. Einstein had predicted that the sun's immense gravity would bend the path of starlight passing near it. During the eclipse, astronomers were able to measure the positions of stars near the sun's darkened disk. They found that the stars appeared to be shifted from their normal positions by the exact amount that Einstein's theory predicted. It was a stunning confirmation. A profound and abstract idea about the nature of reality, conceived in the mind of a physicist, was proven true by a subtle, gentle bending of ancient light. It is a testament to a universe that is both mysterious and deeply knowable. 149. You are a vast collection of world lines, the interwoven paths of your atoms through spacetime. You are not a single solid object, but a complex and harmonious society of trillions upon trillions of atoms. Each one of these atoms has its own unique history, its own world lines stretching back through time to the heart of a star. Right now, all of these world lines are bundled together, traveling in near-perfect unison to form the being that is you. They are tracing a single collective path through the 4 dimensions of spacetime. You are a temporary and beautiful pattern, a fleeting symphony of countless ancient journeys, all brought together in this quiet moment to experience the universe. It is a profound and intricate dance happening within you right now. 150. All of reality, in the end, is a story told in the universal language of geometry. If there is one single idea to rest with, it is this: the universe is a shape. The forces we feel, the paths we follow, the flow of time we experience, all are consequences of the beautiful, dynamic, and invisible geometry of spacetime. We are living inside a great 4-dimensional sculpture. We are made of its substance, and we are guided by its contours. There is a deep and abiding peace in this geometric view of the world. It is a universe not of chaotic forces, but of elegant forms and graceful natural paths. It is a cosmos whose deepest secrets are written not in a complex code, but in the simple, beautiful, and silent language of shape. And so our quiet wandering through the vast, star-lit landscape of spacetime begins to draw to a peaceful close. The gentle current of ideas that has carried us through the night now slows, widening and becoming still as it approaches the great, silent ocean of sleep. The distant lanterns of thought, which illuminated the bending of light and the flowing of time, now begin to fade, one by one, leaving only a soft and comfortable darkness behind. There is nothing left to explore, nothing more to see. The journey is complete, and you have arrived at a place of perfect stillness, a quiet harbor at the edge of the night. The great cosmic story has been told, and now its final, silent pages turn toward a chapter of deep and profound rest. Tonight, we have drifted through a universe far more graceful and mysterious than we ever could have imagined. We let go of the idea of a world of pushes and pulls, and instead felt a cosmos of flowing shapes and gentle currents. We imagined the silent, invisible fabric of reality, a deep and responsive material that holds everything in its embrace, curving gently under the weight of sleeping planets and burning stars. We listen to the deep music of time itself, a great river that flows at its own pace in every corner of the cosmos, slowing to a crawl in the deep valleys of gravity and rushing forward in the great empty plains between the galaxies. We watched as ancient starlight, a timeless messenger from the dawn of creation, followed these invisible contours faithfully, its long journey a testament to the beautiful underlying geometry of the world. We felt the universe as a single, interconnected whole, a place where matter is just sleeping energy, and space and time are two threads woven into the same shimmering, four-dimensional tapestry. And you are a part of this deep and flowing reality. The same gentle laws that guide the most distant galaxies in their silent cosmic turning are present with you now, in the quiet of your room. The very gravity that holds you softly in your bed is your own personal connection to this universal curvature, a small, gentle slope in the fabric of spacetime that you can call your own. The atoms that make up your body, the carbon and oxygen and iron, were forged in the hearts of stars that lived and died long ago, and they have been following these same graceful, geometric paths for billions of years, drifting on cosmic winds to finally find their rest here with you. You are not just an observer of this universe. You are a piece of it. You are a quiet, breathing pattern in the great tapestry, a way that the cosmos has, for a brief and wonderful moment, become aware of its own profound beauty. So now there is nothing left to do but to let go completely. Let the last thoughts dissolve like mist in the morning light. Allow your awareness to soften, to expand, to merge with the quiet darkness around you. There is no need to hold on to anything now. You are safe, you are held, and you are exactly where you need to be. Let your body feel heavy and peaceful, sinking gently into the support beneath you. Let your breath be the soft, silent rhythm that carries you across the final threshold into sleep. May your dreams drift like a lonely planet in a silent orbit, following a path of perfect, effortless peace. Rest now. The universe will continue its silent, graceful dance while you sleep, holding you safely in its vast and gentle embrace. There is only peace here. There is only rest. Good night.